Here's some fun code calculating numbers belonging to the Fibonacci series, which simply means the next number is a sum of the last two numbers. And so here's an extremely short script that shows us how proficient Python can be with space. Again, here we define two values just in one line, variable a and b. A is 0 and b is 1. That is our initial condition. And then here we have a while statement. So here we're introducing a while loop. And the condition for the while loop is that continue this loop until b is greater than 50. If it's 50 or greater, then it stops the loop and the program ends. And then here again, within the while loop, similar to the if command, we see the indentation here. Indentation is always the same. A quick note about the indentation: it should be 2 or 4 spaces or a tab. Do not mix tabs and spaces. That is bad practice. Select one kind. The default is 4. A lot of text editors have an auto indentation function. So when in doubt, stick to 4. So inside these indentations, the first thing that happens is we print b to the screen. So in this case, b equals 1. And now here we're setting two variables. We have here a so-called compound statement. We calculate first a, and a becomes b. In this case, a becomes 1. And then b is calculated, and b is the sum of a and b, the last two numbers. And so therefore now we have 1 plus 1 equals 2. So then we're looping around. B is printed as 2. And now the whole loop continues until b is greater or equal than 50. I've copied the code into my Python window. And I hit enter for blank line and enter to execute. And here are the Fibonacci numbers as expected. 21 plus 34 is 55, which is higher than what we said. And if we want to change that, I simply hit the up button. I scroll up with my cursor. And let's make this a 500. And I execute this. And now we have more Fibonacci numbers. Here are some other examples of loops. Here is our while loop, while x is less than 5. X was set to 1, and in here, very similar to our Fibonacci numbers, we simply print something to the screen and then add 1. So this loops nicely through, and it looks like this. So here I typed the text in already, and blank space, and to execute again. And there we are. In this case, it all works according to the logic. So go ahead and code this and just play around. Call x anything you want, that's your variable. Play around with the numbers, play around with the equation here, and just have fun with finding out what happens if I do this, what happens if I do the other. The best way of learning how to code. Then we have the for loop, where here's an interesting new idea. Num is not a Python keyword. You could put in anything in. You could put in here your own name or your dog's name. But the moment you do that, you're declaring a variable, and therefore then that variable can be used straight here without any further definitions. So in our example, for this variable called num, and then we're defining a range, and the range goes from 1 to 5. But 5 is the first number that is excluded. So in this case, the true range is really only 1 to 4. That's why I put this up here in the corner. A range from 5 to 10 would only consist of these numbers. One last quick comment about the range is if we add a third element to our range definition, we have minimum number, we have first number to be excluded, and here we have the increments. So in this example here, start with 0 and increment by 3, so 0, 3, 6, 9. Now we want to use the for loop, and I say the only reason why I'm adding this here and all the other examples is that now you can see we're creating these variables. There are this list of variables, and then you could of course use them for your coding. For instance, imagine these are numbers that then simply fed into the distance variable of your buffer command, and now it becomes a meaningful variable. In this case, we're just printing it to the screen. Here is another loop, a for number. So in this case here, what we're doing is we are describing a list. So a list is in square brackets, and then the elements are separated by comma. And here now we have a list of 4 elements from 1 to 4, a number in X. So 1, 2, 3, 4, print those 4 numbers. That's how we can work with lists. Let's make a list. In my case here, let's make it a feature class list equals and so you see again the logic here. I created a new variable called Stef in this case, just again to show you can use anything you want as long as you are consistent with your spelling. And now I'm using that variable here simply to print it out. So this variable is set first to river, and then to road, and then to land cover. But now, of course, imagine geoprocessing tools where you feed these in maybe for a clip command or something like that. And then you put the clip command in a loop, and now you're clipping various things in one go. Let's have a look at our different variables and how we can define strings as well. Let me write a string. Here my variable is first, and now the string Stefan is assigned to first, and the string is defined in single quotation marks. We can also define another variable here with double quotation marks. Both are usable. We already defined integers. In this case, I'm defining age equals 30. I can define lists. In this case here, a feature class list. Again, square brackets. And our individual features are separated by a comma and are in quotation marks. Here is a list of distances, maybe distances that we would use to buffer something. And then we can concatenate pieces of string together. So in my case here now, if I declare a name that consists of the elements first and last, then this would result in my name, but without a space. I will show you how to correct that. Here, if I use age, which was already defined as being 30, now we're adding 25, and of course the result would be 55. Here is a neat way of using the syntax, how to add elements together to make an English sentence as a result. So in our case here, we calculate something, and then we say print, and first of all we say print the value of I is with another quotation mark. This is then followed by I here, and then I'm ending up with a full stop. So the strings of course are printed without the quotes, and when we're adding these elements, already automatically a space is inserted between the two items. because that's how our English language works. You can do strings with double quotes or single quotes. Just as a reminder, you cannot always copy those quotation marks from text editors, such as Word, for instance. The only exception would be if you use a specific font, which would be Helvetica. That would be allowed. All other ones, the quotation marks, if they look like italics and not straight like this, then they will not work. They have to be straight like you see over here. And also, and we will have to deal with that when we're defining workspaces particularly, or output folder path names, that the backslash is in Python a special character, and that can have consequences. So here then on the right side, and you can play around with this, and I encourage you to type this in yourself. So we have here good afternoon in two different ways. But if we're typing this in here, this won't work, of course, because we have single quotation mark. This here would be interpreted as being your string, and then here we have something that is simply going to be missed. And it would give you a error message, invalid syntax. If you add a backslash before the quotation mark, then it would be interpreted as a quotation mark, and you can use this string. Here's an important Python command to set or query the workspace within our environment settings. So if you add nothing else and you simply hit enter, it shows you your current workspace. And in order to change it, all we need to do is define our new workspace, which is this one here. On my USB drive, I have a folder called new data, and if I hit enter, now I'm getting a syntax error. And if we read further on, it says here in position 1213, so here we have an issue with our backslash. It says malformed \n character escape. This code here /n means create a new line. So we're violating an internal Python command using just the backslash. So what are the options to avoid this error? So what syntax would work here? Let me repeat this last command. And if I add a second backslash and I hit enter, and if I now repeat just the query of the workspace, there I get the correct result. There are two other ways how you can do the syntax for your path. One is, instead of using two backslashes, is using one /. And if we hit enter, and if we query this again, it works also. And in both cases, it gives you the /. These are both identical in their meaning. Python translates them both correctly. And then there is a third way what we can do. If I go back to our very original with a single backslash, if I add an R in front of this code, then this R is interpreted as, read this as a raw file and don't interpret this as any character escape functions, like for instance /n for new line. And now if I query this, there we have our proper backslashes just as we had before, because we used the R command. Here is a summary of what I just demonstrated. We have three options to type our paths: double backslash, single /, or single backslash with an R in front of the quotation marks. And the same thing that just happened to me now when I had a folder called new data. Here I have a folder that also starts with an N, and in front of the slash here, then it would translate it into this, new line and not show the n at all. So this is how it actually would be translated, except it doesn't do that. It gives you an error because it doesn't make sense. Simple solution, add an R in front of your quotation marks. You also recognize in the exercise I use double quotation marks. Single quotation marks are also acceptable. And here you see /n starts a new line, /t would insert a tab. And you simply don't want to remember all of these, and so therefore the R is getting you out of trouble. R stands for raw. A quick last comment about concatenating strings, so putting strings together. So here I have two variables, height equals 6.1, name equals Stefan. And now if I want to make this sentence as a result, maybe from some analysis, this sentence here has 4 elements, Stefan, my variable, the height, another variable, and then 2 elements just to make an English sentence out of this. And then these 4 elements are separated by a comma. Strings are in quotation marks. And then the variables are there. And as we had learned earlier, Python is adding a space automatically between those elements. Here is something that demonstrates that you can add anything you want that is worthwhile. For instance, the time a certain file was created. So you basically put a timestamp on when you did a certain analysis. This is not important for you in this class or for your projects, but this may become important if you work for a corporation and you just need to know when things were done. Or if you are working in a larger team, you want to make sure that you're not using the latest version of a certain file. That's all for today. Until next time.